Hello, folks. Welcome back to Learn Synthesis with Pure Data. This is Series 2, Episode 5. In this episode, we're going to look at ring modulation. Back in Series 1, our synthesizer had tremolo in it, a form of amplitude modulation. But now we're going to look at ring modulation, which is basically like really fast tremolo that allows you to create what are called sidebands, which is just more frequency interest in the sound that you can then filter and work with. So let's get started. Okay, so here we are. And what I have here is everything from episode 4 copied over into a new folder, episode 5. We got our audio folder, which as we build more modules, will be used by other modules to store audio in, just like our granulator is able to open and save from that folder as well, which we accomplished last week. And here's the modules.pd file. This is what you open up to work with modules. So far, we only have one, but we're going to be making a second one now. And so behind me, I have my modules file, and granulator _ mono tilde is loaded up in it. I resized it a bit, made the waveform a little bit less tall so that I could fit it into a 320 by 240 pixel rectangular area. The reason why I did that is I am going to try to make my modules 240 pixels tall, where basically they'll all be like the same height, and you can lay them in next to one another and hook them up. But what I'm going to do first of all is actually close the modules window, because we're going to make our ring modulation module its own abstraction. And so the first thing I'm going to do is save it to this folder. We're going to go up to File, and we're going to go to Save As, and let me find the folder on disk. Let's see here. Shortening that. Let me make sure I'm in episode 5, and I'm going to call this ring _ mod _ mono. All the things that will be handling just one channel will have the word mono after them, just like the granulator we have here is mono. That way I can make stereo counterparts in the future. A lot of that will go into season 3 or series 3, because right now we have more to go in series 2, more concepts to cover. So anyway, the way I'm going to start this is we're going to have to figure out, I know I want it 240 pixels tall, but we're going to figure out what controls we want to have in this. And I am going to put in basically 1, 2, 3, 4 main controls. Now, do I want to put them in as vertical sliders? I think I will. So I'm going to hit Control-Shift-V. And we're going to have 4 of these. So I'm going to just duplicate them out. I probably should have duplicated them after I figured out what the ranges are going to be. But actually, some of these are going to be different ranges than others. So basically, in working out our size, what also I want to have appear in this is going to be an array. And I hit Control-Shift-A there as the shortcut. You can also go to the Put menu. And the array that's going to be seen is going to be called $0 underscore. Let's see here. The one that we want to see is going to be the, I'm going to call this signal. Because remember, this will also be visible as a table name. So what do I want it to be called? We'll call it waveform again, just like our other ones. Okay. And I like Bezier curve better than points as far as the display is concerned. So if we have these four things in this table here, let me work out here a little bit of calculations of space. Okay. Well, let's just make it first of all. Let's try 240 by 240. So I'm right clicking here on the canvas in space. And I'm going to say, let's say 240 by 240. Well, we got to check off graph on parent, and we are going to hide the patch name. 240. Margin 100, 100 from the side, that's fine. So now we see our red outline. That is, that's where we were going to fit things in. But I think I know what I can do. Let's delete some of these extra. Yeah, I should have resized them, all that sort of stuff first. So let's make this 100 tall as far as its range concerned, 0 to 100, which I'm going to make it height 100 as well. Well, if you want to be able to get every single pixel, 0 to 100 is actually 101 different values. So there we go. Okay, and this is going to be called, well, we'll name it afterwards. Okay, so there we go. We're going to have one of these for input. We're going to have one of these for output level. So you can control how much sound is coming into this module for the effect, how much is going out. And then we're going to have a controls for the frequency and the depth. Or you can call that rate and amount. And so let's just duplicate. Four of them. There we are. Just trying to space them evenly, much as I can. That's close enough for now. So now this table, let's make it fit. So we can right click on it, go to its properties. This one shows its size and values. That we're going to address later. But what we can do with this table is make its size fit better. Now, 220 is a good width because the overall module is 240 wide. And the height, try 80 and see what that gives us. Just about, yeah, that's good. That'll be good. That'll be good. We'll go with that. People are welcome to use their own colors and size, but this is just a good way of showing you how it's a lot of the pure data patches out there don't really look so nice. How you make them look so nice? How you make them look nice? And by the end of this series, it'd be nice to have a few modules made that could be hooked up to one another to make stuff happen. Okay. Now, like I've been doing, I am going to make a subpatch called PD loading. And this is going to do some things. Now that I've made that subpatch, that's this window here. We're going to make a load bang at the top. Now, since we have other things that will have DSP1 in it, but we can't rely on that. Maybe just have this module by itself. So we have to put in the message to turn on audio. PD semicolon enter PD DSP1. Yep, when you hit enter, it doesn't automatically go to the next line. Here, I'm going to put a bang here. I like to do that under my load bangs because while I'm building, I may want to hit that bang to get my initial values set. And so one of them is going to be this. And the next one is going to be getting our sampling rate because we're going to use that for a few things. And there might be some other defaults that we want to have, like slider positions and things, maybe, as we start. So we'll add those later if we need them. Sample rate. That's right, it has a tilde at the end of it. And we're going to put after that times you know what? How about we just send it out? Let's just make a send like we've been doing. Send $0 underscore sample rate. Alrighty, and there we go. Okay, so we can Control W or Command W in Mac to close that window. Yeah, we are going to have to make our inlets for a signal coming in. Inlet tilde. And then right after that, that's going to go straight to a send tilde, because it's audio rate. Audio input. Okay, and then we'll need the opposite down here. Outlet tilde. Oops. And it's basically receiving from a receive. Audio. Oh, I got to put the $zeros in. $0 underscore audio underscore output. And then hook that up. So I got to fix that one above. So now our sound can come in and out of the module. But yeah, we want symbol to names to have a $0 on them. So these different modules will get their own unique number that I've been talking about all these episodes, and you can have multiple modules in the same space, and they will all have unique symbol names. Okay, now we are going to have here a subpatch just for our ring modulation to occur. PD modulation. Okay, and now this is where we're going to put the bulk of our stuff. Go into edit mode here. Now our audio input is coming in, so we have a receive tilde, audio input. With the $0, can I get one, please? Okay, so our audio signal that's coming in from the outside of this abstraction patch comes in through the inlet, gets sent wirelessly to here. And now what we want to do is the main thing that's going to happen to do amplitude modulation is basically taking a good old star tilde and then modulating its amplitude with an oscillator. Now, we will eventually make two chains. We're going to make a wet and a dry chain, basically. But anyway, the way this oscillation is going to occur is we're going to have an oscillator, an OSC tilde. It will get fed information. I'm seeing some red over here for some errors. Let me see. Receive. Okay, that's when I made those receives and included the $0. There's no corresponding send for this receive, but we didn't make it yet. That's why. Here. I'll just make it. It'll be at the bottom, although we're going to use it later. We'll make a send. $0 underscore audio underscore output. There we go. So now it has nothing to complain about. All right. But as I was saying, we're going to have an oscillator that basically oscillates the amplitude value. And the way we're going to do that is this oscillator will have a frequency that will be given to it that we can control. And we'll work out some math later to see how that goes. But for right now, we're going to receive right here. Just a regular R. Now, we didn't make the send for this yet, so it'll probably complain and give me an error. $0 underscore. We'll call it rate. And underscore send, because it's going to come from a slider that's going to be controlling the send. Okay, and that will be controlling the frequency of the oscillator. Alrighty, so what I'm going to do, let's move this over. Can I fit all these on screen? Well, especially if I don't make this so wide. This actually isn't going to need to be wide at all. Let's put you over here. You are going to need more real estate. All right. So this will be our rate slider here. So we're going to right click on it, go to properties. And for now, its range is going to be 0 to 100. We're going to change that eventually, but for now, to demonstrate things, that'll be good enough. So it's going to be sending out $0 underscore rate underscore send. Now, I always like to put a receive in on these things because eventually there may be receives, especially when I have these modules have multiple inlets so they can receive from other places and stuff like that. These receives will already be set up. Rate. Yeah. Can't think and talk at the same time. Okay, so that can send us some frequency values to here. Now remember, I intended this to be an input slider, input level. So let's see. Let's set that up. $0 underscore input level underscore send. input level receive. Okay, and its rate range is going to be 0 to 1 for the amplitude level. And let's just label it in. I should probably label the other ones that I'm making too now as well. Let's see if we can fit this in here in a way that looks nice. That looks pretty good. There we go. And this is our rate. Why don't we put rate? It's only 4 letters, shouldn't take up too much space. And it's clear to anyone what this does then. Okay. So anyway, yeah, we wanted to control the level of our input. And we could do it right here, but right here, we have a little more space. So let's do that. I didn't have to disconnect this one. I can use it. Basically, we're going to be receiving from that slider, receive $0 underscore input level underscore send. All right, that's the send symbol from that slider. And then what I'd like to do to make things sound smoother, I know we haven't done this in the last patch, but I'm going to be adding this to some things. You could hear like little clicks, little artifacts when you move sliders up and down if you don't smooth out their output. Because these things are coming at the control rate, and we want to convert them to the audio rate in a way where it goes from value to value a little bit smoother. So we're going to send this to a pack object, F, which stands for float, and then 50, meaning the number 50, because we're hooking this up to line tilde. And so what this does is it'll go to whatever number comes in to pack through the left inlet. Whatever number comes in there is considered to be the float. And that number goes to line with this 50 as a single message. And 50 means 50 milliseconds. So whatever number you move the slider to, it'll do it in 50 milliseconds. And that will get rid of any kind of artifacts or clicks that you would hear, because the numbers being sent are being sent at the control rate. Okay, so that controls our level coming in. Very good. Next, we're going to have 2 star tildes. Two of them. One of them is going to be our dry signal, and one of them is going to be our wet signal. So I hook them both up like that. Now the whole point is we're going to have an amount slider here, which means how much ring modulation is going to happen. How much of this oscillator that we didn't really finish building yet, how much of that is going to affect the sound? Well, we're going to make this amount slider a range of 0 to 1. We'll give it a send symbol, $0 underscore amount underscore send. Amount underscore receive. And we can abbreviate this. Well, it's only one extra letter, amount. Let's see, that should fit and still look okay. Maybe AMT would look better. And it would be clear what it is. Label, remember, is just a visual indicator of what the thing is for the user. PD doesn't worry about what it's named. Okay, so now that amounts slider is going to say how much of the sound is going to be unaffected and how much is going to be affected. Because if you just have an affected slide, this being an amplitude modulation, well, what happens if you're not modulating. You don't hear anything because it gets zeroed out. So we want to be able to hear basically the sound unaffected versus the sound affected. So we're going to receive $0 underscore amount send. And now this is a range of 0 to 1. So when it goes up to 1, we want it to be sending this side, which will be affected by this oscillator. We'll put another star tilde there, but this is where it's controlling how much of the modulated side is coming through. Okay? So we'll put it here, and we're going to put it with its own pack F50 and line tilde. So I just selected those, hit Control D, Command D, and Mac, and you duplicate them, drag them down, because they're the same things, might as well use them. So 0 to 1, when the amount slider is turned all the way up to 1, you're getting your modulation on this side at full strength. It's at 0.5, it'll be half strength. Now what we need to do over here is really initiate the opposite. I'm going to pull this down a little bit because we're going to put a little bit more in. The way to get to opposite is the way we've done a lot of things. You type swap 1 and a minus sign. And then connect up. It's very easy after you successfully get swap 1 typed in to forget to connect the right outlet to the right inlet. Because what this is doing is it's sending 1, which is representing like the right inlet. We're just giving it a creation argument. So it has a number. We're not going to change it. So that comes out the left outlet. 1 minus whatever comes in the left inlet is coming out the right. That's all swap means. Whatever comes in the left inlet goes out the right. And whatever comes in the right inlet goes after the left. But if you put a creation argument in, that will automatically be considered whatever's on the right side, and it will go out the left. So we instantly get a 1 minus whatever this number is, which basically means we're getting our inverse. When this is all the way up at 1, this side will be all the way down to 0, because it's 1 minus 1 equals 0. And everything in between. If the slider's up to 0.75, 1 minus 0.75 equals 0.25. So we're going to be getting the opposite. And we want that so that when we're reducing the amount of ring modulation that we have, it makes up for it with this, the corresponding amount of non-ring modulated sound. I'm going to get this cable connected sooner or later. There we go. Here, I'm always like this, just trying to get things right. All right. And these two signals get added together with a plus tilde. There's one more thing I'm going to put in before I connect this up. We'll see that in a moment, but let's add our oscillator. What is this amplitude modulation that we're going to do? Well, first of all, our oscillator here is kind of like a sinusoidal shape. That's fine, but we need to change its range. Remember, this OSC tilde is going to oscillate between +1, -1, +1, -1. Well, we got to make sure it's oscillating between 0 and 1. So the way you do that is you cut it in half by multiplying star tilde, 0.5, and then add 0.5 to that. And basically now we're getting a range of 0 to 1. Here, I'll show this quick You don't have to add this because I am going to delete it, but just so you understand the concept. Toggle Metro 100 tab right test, I'll call it. So I'm going to make a quick array here called test. All right, there it is. So this is so we can see. We're going to take this signal out of here and put it into tab right. Now this is before this math here. Well, actually not from there. Straight out of the oscillator. Now the oscillator does not have any frequency value. Oh, tab right. I have a typo. Tab right tilde test. Okay, there we go. Now we can hook this up. Let's give it a frequency just to start. This won't really affect much of anything. It's just for now. Let's oscillate it 2 times per second. And then we hook it up to tab right. Now we got to turn DSP on. Shortcut is Control /. DSP's on. Then we go into run mode to turn on the toggle. There we go. Now, basically this is going up and down between -1 and +1. Let me change the size of this so this looks better. Just quickly, let's display 1 second's worth of sound, so we'll make it 48,000. Its side, or no, what am I doing? It should be 480. Not the sampling rate itself, but 1/100th of it, because it's basically 100 times per second. All right, well, whatever. But anyway, you see it's going below the center line. We want that to be like this. By basically cutting this in half, you're basically making it half the size, and then adding 0.5 to it pushes it up, so now it's between 0 and 1. So let's hook this up. Now it's just going, you see it's not going to the lower half of the array. All right? Because basically what we want to do is modulate our amplitude between 0 and 1. We don't want it to go down below 0. It'll just wrap around and it'll sound like we're getting twice as many oscillations per second. Okay, so now what is this going to do? Well, actually, this is what it should be set up as. Here, let me move this down a second. We're going to have to put a star tilde in here. And so this is where this signal here gets modulated. Its amplitude gets modulated right here with this star tilde. Now it needs to go to the next one, because this is regulating how much it's getting modulated. So it needs to go to that one as well. Okay, let me just move these down so the whole picture looks a little bit better. How does that work? There we go. All right. Now, we're going to temporarily just listen to things by putting in a DAC. And turn down your headphones just a little. if you're listening to this on headphones, just in case this is loud. No, it's not. Oh, the other values haven't gone through yet. But, yeah, so, and plus my input slider's down because now we're hooked up to that. Oh, wait a minute. Yeah, we're good. We're good. Turn up the input. All right, let's turn on frequency rate here. Okay, I was hoping we'd hear something. Is audio on? Audio on. Okay, let me double check. See what we're doing wrong. We have a DAC hook up to here. These are being added together. Swap one. And over here. Well, the amount slider's down. No, I did move it up. No, I didn't. That would do it. We need to get some values in there. Oh, but that didn't cause it. Let's see here. Well, our frequency here is 2. That shouldn't affect it. Our sound, oh, we don't have an ADC coming in. We're modulating nothing, basically. Let's get our ADC coming in. This is just temporary. Okay, so now I hear myself. All right, so if we turn the amount slider down, I sound normal. Hold on, let me, because I'm probably sounding double right now. Okay, so now I should be muted through my main mic in OBS, but not through PD. So this is unmodulated sound, and as we turn it up, the modulation gets faster. When it's slow, you can even count how many times it modulates per second. But as you turn it up, it gets crazy. Now, here, let me turn this down. I said we're going to have to change the rate range because this isn't useful. I'm going to try 1 to 10,000. And we're going to hit the linear thing here and change it to logarithmic, which means as you move up the slider, it's in a logarithmic scale rather than a linear one, which is better for frequency values because they get further and further away from each other as you go higher in frequency. Okay, and we are using frequency values that are in the audio rate now. So turn up the amount, and here's the effects you can get. Wow. Yeah, baby. How are you doing? Let's see how high we can go. Properties. 18,000. So you can go higher. Well, right about here is where it's still useful. So I'm going to probably make it 16,000. Okay, so we get a better range now. Yeah. Okay, I'm going to turn off DSP. And there we go. I'm back on my mic. Okay, so now let's take out the ADC that we have here and take out the DAC. There's one more thing we need to add here because we have our output slider where we can control how hot of a level we're sending out. Let's go here and say out. And we need to give it symbols, $0 underscore output level underscore send. Give it its receive output level underscore receive. There we go. And then make its range 0 to 1. It's already on 0. Let's do 1. Okay. So that we're going to put right here. In fact, we're going to borrow this whole thing here. Control D, duplicate. Then, what am I doing? Oh, we need another star tilde. And we need to rename this. This is called output level send. Star tilde. And it goes out there, and this output level comes on this side. Basically, when you hook up these modules, just like if you had a bunch of guitar pedals going into one from another, you can regulate how much it's taking in from one, from, you know, wherever the signal source is. And here you're regulating how much gets sent out. So let me resize the window down to as much as the space is that we're using. And then I'm going to have to test this in modules.pd. Save there, and now save here with that closed. Okay, so now close this. Do I have my folder still here? Good. And it's called ring mod mono tilde. Should be in the file name. Just to follow the common practice that, oh, I do. I have it there. It's there. The reason why we do that is when something's meant to be an abstraction, if it does have audio going through it, it's customary to put a tilde on it, just like you would with audio rate objects. It's more of a custom. Things would still work if you didn't do that. But so let's take this. I'm going to disconnect the DAC here, and we're going to add this module. I guess it'll fit right here. Do it. We just type its name, which is ring underscore mod underscore mono tilde. There it is. Need to give it some colors. But I can do that later. Don't need to do it on screen with you guys right now because I've been doing plenty of that throughout this series. But now let us test things out. audio should be running. But remember, the granulator is the source. My input is going straight into it. And so this doesn't have a through. I didn't make a through where the sound will go through to the next thing. This has to be plain to do it. Okay, so now we're going to be hearing granulated sound along with some ring modulation. We got to turn up the inputs here as well as the output. I should be hearing stuff now. There's probably some debugging to do. Here's what I'm going to do to test it. Let's make a DAC. Everything should be coming out of the granulator just fine. That one's already been debugged. Granulated sound along with yeah, it's our new stuff here. Let's go here. Let's right click, go to open and see what's going on. Here it's inlet tilde is going to send tilde $0 audio input. And here, this is receiving $tilde $0 audio output. And it goes out, the outlet. Everything is correct there. Let's go into the modulation. See $0 audio input. Send $0 audio output. Now, I think I know what it is. I think I know what it is, even though that stuff is all looking correct. Let's do this. And this is something we're going to have to add to its loading menu. Hello, 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 hello. Some ring modulation. There we go. So now we're going to be hearing granulated sound. So what was the problem? These sliders were just sitting there at 0, and their values didn't get sent. An amount of 0 and a frequency of 0 would be fine, but they didn't get sent. And so we need to go in here into loading and make sure things have values to begin with. So I'm going to add 2 more bangs here. Okay, and then I'm going to disconnect these things and put everything in order here. This will be a simple fix. Okay, turn DSP on, yeah. And then what we'll do is after saving it and closing it, I'm going to test it out. I'm trying to get people to do that are taking my classes. Don't really like to do it. They just send it to me anyway. All right. Let's see here. Now, we should send all of our sliders some good starting values. 0. That's going to go to the frequency and amount sliders. So I'm going to say send. Hey, we're going to get the receive finally used. $0 underscore rate underscore RECV. So rates receive finally can receive something. And then we're also going to send this to something else. Let's just duplicate this and type it in. Oh. All right, it's going to rate receive as well as amount. So basically, the ring modulation won't be modulating when it starts, but signal will flow through it. And this is called amount receive for this slider. Basically, we're giving these sliders values to start. Oh, I'm sorry, I had this off screen the whole time. But, you know, we're sending values to these two sliders. Those values are 0. In fact, if I go into run mode and hit 0 now, they're zeroed out. Now, do we want the input and the output to be zeroed out to start every time it starts up? I guess that's a matter of preference, but I'm going to make it 0.8. Basically, make sure it's not blasting, but it's on. And you can hear stuff right away. Now, this message is going to go to send $0 underscore input level underscore receive. And output level. Now, I didn't hook up that array. Well, we needed to test that things worked first. The array we can add. Okay. Now let me hit this. Here, actually, I'm going to move these just to test it. Test so I don't have typos. Yep, you see they went to about the 8 position. Okay, now I'm hitting save here with that closed. So that way the abstraction doesn't have one of its internal windows open when stuff goes on. Now let's save. I'm going to close PD. We're going to open modules again. All right, so now we're going to be trying again to granulate sound as well as use ring modulation. All right, so now we're going to be trying again to granulate sound as well as use ring modulation. All right, so now we're going to be trying again to granulate sound as well as use ring modulation. Modulation. All right, so now we're going to be trying again to granulate sound as well as one thing use ring modulation. I might do in like the final version of this is divide this up into 2 sliders, or a slider and a radio box, because basically the amount here is going from really small, I mean the frequency here. Actually, it shouldn't be at 0, first of all. Oh man, I have to open it up to change it. Open. It shouldn't ever be a frequency of 0 because then it's off. As long as the amount's down. Okay, the logarithmic thing did basically put it there. It gave it a minimum value because a logarithmic curve cannot be 0. Okay, so there we go. But yeah, for the final version of this, I'll probably have this and a radio box here where you can multiply its ranges. So that way you can get some tremolo values as well as the higher values of ring modulation. In fact, this this would actually be a pretty easy enough thing to do. No, that'll be for series 3. When I start making some of these modules that I'm doing in this series better, taking them to the next level. So anyway, one thing I do want to do is get this table working. So let's do that. Let's go into here where we have modulation. So that way we can kind of visualize things. Now, what do we want to see? Basically, right down here before going out. So that way, if you turn down things and if you have your output down, it'll visually show that in the table here. So anyway, I'm just going to do a load bang because this table is going to be on from the start. And that load bang needs to be a 1. So I'm going to send a message of a 1 to Metro 100. And tab right. What is this called? $0 waveform. And we need to feed in the actual audio to tab right. So this means it's always going to be on. A lot of times, I like to put in toggle switches so people can turn them on and off. You've seen I've done that before in series 1, not in this one. That might be a feature I'll add as time goes on. Basically, a toggle box on the outside that sends to a toggle box here to turn it on and off. But right now we'll just have it be on. Now, one other thing. We should be seeing some signal there. Oh, the granulator is the ones that's hooked up. So as long as it's not running, we're not going to see anything. But another thing, one more thing in loading. The table size. Actually, I'll put it in here. The table size should be 1/10 of your sampling rate in order to display things in a way that look all right. Since it's being tapped 100 times, every 100 milliseconds, which is 10 times a second, the sampling rate, which we're going to receive here, sample rate, is going to get divided by no 100. No, by 10. And then we're going to send that as a message to the table, which is named $0 underscore waveform. Let's not have typos. Resize $1, meaning the variable coming in. Oh, and to make sure this is wireless and is going out to the table, we have to put a semicolon before and a semicolon after. Now, in order to get that sent right now, I got to go into loading and hit this bang. So all our initial values are sent. Okay, so I'm going to go back to here, save, after you close all the sub windows so that this gets saved, and you won't see the sub windows open the next time it comes out. So anyway, let's just play. All right, so now we're going to be trying again to granulate sound as well as use ring modulation. All right, so now we're going to be trying again to granulate sound. I should be seeing something. Use ring modulation. All right, so now we're going to be trying again to granulate sound as well as use ring modulation. Did I never send this one? So now we're going to be trying again to granulate sound as well as use ring modulation. All right, so now we're going to be trying again. Actually, I've changed my mind. I'm going to divide this by 100. Modulation. All right, so now we're going to be trying again to granulate sound as well as use ring modulation. All right, so now we're going to be trying again. Which means we need to go here to loading, hit that bang again so sample rate gets sent. All right, so now we're going to be trying again to granulate sound as well as use ring modulation. All right, so now we're going to be trying again to granulate sound as well as use ring modulation. All right, so now we're going to be trying again to granulate sound as well as use ring modulation. All right, so now we're going to be trying again. Let me test this. To granulate sound as well as its size is 100. Modulation. All right, so that's why it's not looking right. Be trying again to granulate sound as well as use. That's why it's not looking right, because the table's not being resized. Usually when you want to resize a table, I thought it was basically you address the table, waveform, resize, $1, which is coming in from there. It should be 480. Let me try it this way. Do a send $0 underscore waveform. And we want to tell it to resize. Okay, so what I'm going to do, go into loading here. This is where the sample rate gets sent out, right here. It is hooked up, right? Send $0 sample rate. Oh, I know what the problem was. So easy to do. This should be receiving from $0 sample rate. I left out the $0. As soon as I saw that, I was like, I know what I did wrong. So the other message would have worked too, but I think it'll also work like this. If not, I'll go back to the other way of sending the message. But basically, I'm just going to hit this bang, and then right click on the table, go to properties, 480. There we go. Now it's the right size. Save it here. And then play. All right, so now we're going to be trying again better to granulate sound as well as use ring modulation. All right, so now we're going to be trying again to granulate sound as well as use ring modulation. All right, so now we're going to be trying again to granulate sound as well as use ring modulation. All right, so now we're going to be trying again to granulate sound as well as use ring modulation. All right, so now I'm going to try the other value just quickly. Granulate sound as well as use ring modulation. All right, so now we're going to be trying again to granulate sound as well as use ring modulation. All right, so now we're going to be trying again to granulate sound as well as use ring modulation. All right, so now we're going to be trying again to granulate sound as well as use ring modulation. All right, so now we're going to be trying again. That looks better. To granulate sound as well. Divide by 10. Use ring modulation. All right, so now we're going to because it's 10 times per second. To granulate sound as well as use ring modulation. All right, so now we're going to be trying again to granulate sound as well as. All right, folks, I think we did enough for this week. So now we're going to be trying again to granulate sound. And Gonna save this stuff.
All right, so now we're going to
Let's get a nice screenshot.
Granulate sound as well as use ring modulation. All right, so now we're going to be trying again.
Thank you for joining me. I hope you enjoyed this little adventure in getting some ring modulation.
Trying again.
Can color your objects at will.
Use ring modulation.
So anyway, folks, stay free.
We're going to be trying again.
And take care.
Sound.
Probably should have stopped that before. Well, you know me. All right, folks, stay free and take care.